Hi, everyone. Thank you for taking the time to join us for today's What's New webinar. My name is Ryan Hallback, and I am a Principal Intelligence Analyst here at the Vertex Project. And today I want to take some time and just show you how we use Synapse to analyze the Contileaks data, and specifically gain insight into how the Conti threat group leveraged cryptocurrency for their CNO and extortion operations. In February of this year, there was a Twitter account with the handle of Contileaks that leaked about over 6,000 internal Conti threat group messages that they obtained from an internal Conti Jabber server. Like every other security researcher here at Vertex, we wanted to get our hands on the data and take a look and just see what we can find in that data set. The one thing that we really wanted to do, however, was take a look at the Bitcoin activity that was in that data set and see what it would give us insight to regarding their operations. As analysts, we commonly get access to the common CNO indicators like IP addresses and FQDNs, and we have some insight into CNO infrastructure. But what appeared to be different about this data set was how it would give us the opportunity to actually juxtapose their internal and private operational data that they talked about in their chat messages with some of their cryptocurrency transaction data. This in itself seemed like an analyst's dream, so we wanted to take a stab at it. So for today, what I want to do is just kind of walk you through how we approach the data, how we use Synapse to programmatically ingest the leaked chats, extract and enrich some of those indicators, like those Bitcoin addresses that were contained and leaked in those chat messages, actually analyze the blockchain data and gain some key insights, and ultimately how we were able to identify some previously unreported victims and Bitcoin addresses that were used by Conti to help facilitate some of their extortion operations and even consolidate victim payments. So just let's get started. On February 27th, what you see here is we have a Contileaks account. That's the handle that was used to leak some Conti data. Specifically, what this user did was put out a tweet containing a link to Anon files where the data was hosted. We needed to get this data into our system. So what did we do? We used a combination of several power-ups to pull in that data. Specifically, what we did was we used our Twitter power-up to pull in the tweets. And then after that, what we did was we used our file parser power-up to then go ahead and pull in the file that was associated with that data. So this is just some of the the chain of what that looked like. So if I pivot through these URLs, what you'll see is how these files were all connected. And going to the subfiles, the files that were contained in that archive, what you'll see is how we have just about over 300 files, or really close to 400 JSON files that were contained in that archive. We then took those JSON files and consolidated them and put them in a single JSON-L file. And we used our ingest tool to then go ahead and reason over that file. And we wrote some storm code to tell it, our system what to do. Specifically, we created INET web messages to represent each of those chat messages that were contained in the JSON file. So we created those messages. We tagged them with an internal story tag of Contileaks to indicate that they're going to be a part of our research. And then in addition to pulling in those messages, we also used our scrape tool to scrape out any easily identifiable indicators like IP addresses, domains, and Bitcoin addresses, and link them back to the original chat messages so that we can see where they came from. And then lastly, and finally, after we had all of this data added to the system and tagged, what we did was we went ahead and translated the messages that were in Russian to English so that we can easily take a look at that data and analyze it. So what did it look like once we got it into our system? Here, what I'm going to show you is just about a quick summary or synopsis of some of the web messages that we pulled in and tagged with the tag of Contileaks. Here, just sorting by time, what you see is we pulled in the messages, which were primarily in 2021. We did subsequently go back and pull in some messages from 2020, but the bulk of the data, those 6,000 messages that were released initially, they came from 2021. You can see how we represented those Jabber messages in our system. We created INET web message nodes, and we're able to track the time that the message was sent, who the message was sent from, the user that received the message, and also the text, the content of the message itself. Like I said, those messages were originally in Russian, but because I don't speak Russian, we needed to translate them. So we, got rid of the Russian text, at least in our views. And we not got rid of it, but we also added English text to the messages so that we can easily take a look at that data. As you can see from the messages, this was a treasure trove of information for all of you who took a look at it. There was a lot of great, information that was released, and it really did give us insight into how they operated. We saw, their hiring process, everything from payroll, even information regarding servers. When we took a look at the data, for an example, when you look at the messages, you can see some of the infrastructure that is called out, whether it's domains, IP addresses, and you see other indicators even like credentials that was contained in the data. So what we did in analyzing the data is we, pulled out that information, and then we also applied tags. That's what we use in Synapse to apply context and contextualize data. We applied tags to the data to indicate what we think it was associated with. So in this case, for an example, we assessed that this message is referring to CNO infrastructure. So we tagged it as such. If I pivot from this message, what you see is what we have linked. We have the individuals who participated in the conversation, so the web accounts. We have some of the FQDNs that were pulled out automatically using our scrape tool, some of the IP addresses that appear to be infrastructure, and we even modeled and linked back some of the credentials. So all of this was very useful for us. Like I said at the beginning of the webinar, one of the things that we wanted to focus on primarily was not just the infrastructure and the typical data that we get access to, but we wanted to kind of explore some of this cryptocurrency activity. And because of that, we wanted to enrich the cryptocurrency addresses that were contained in the data set and analyze the blockchain transactions associated with them. To do that, what we did was we leveraged our block cipher power primarily to pull in data from the blockchain. We have several power-ups that we can use to enrich cryptocurrency addresses. So blockchain, we have Etherscan for Ethereum addresses, but we use block cipher to pull in those transactions. I didn't pull in this data manually. What we did was specifically leverage automation that went out to block cipher for us because we tagged this data with Contileaks. And when it saw this Contileaks tag, or specifically the story tag, it went out to block cipher for us, and it pulled in transaction data for all of these addresses. When we model transaction data in Synapse, what we do is we use three forms to represent that data. We create a node to represent the transaction itself, so a cryptocurrency transaction node. We also create input and output nodes for each input and output that is observed. And we break it out this way because, as you know, for Bitcoin transactions, it accepts multiple inputs and outputs. So we wanted to, and we needed to separate that information out. So for a given Bitcoin address, whenever we're analyzing that data or associated with the transaction, what we have are the inputs. So we have the times and the hash that it's associated with the transaction. And we see the value that's associated with that transaction input. And we also have the outputs. And so when I pivot from that address, this is what you get. You're going to see, what inputs that address was associated with. You also see the outputs that it was associated with as well. So where did it, when did it receive money? And you see where it sent money. And then lastly, because of the way we link data in the system, what you see here is how those addresses are then also linked back to the web messages that they were extracted out of. This is just helpful. This was helpful as we went into, analyze this data. Because as you click on the messages, what you see is just the immediate context. You have not only the cryptocurrency addresses and the transactions that you can analyze, but you also have the web messages right there that you can take a look at in parallel. So you get that immediate context, which is just some unique insight into threat actor operations. So in this message that I have pulled up here, for an example, I see that they're talking about some new servers, some signatures and extensions, and they specifically call out the address that the payment needs to be sent to. And they even call out the Bitcoin value that needs to be sent there. So when you look at all of this as a whole, what you have is the communicating parties, which can give you an idea of their role within the organization. You see the date that they're referring to and the dates that they're communicating. And then you also can come up and see the actual date that transactions occurred. So when I come up here to this output, for an example, and I can select this input as well, when I pivot, I can see what date an output was sent to this address that was referenced, which just helps us confirm that, what they're saying in the messages is actually occurring on the blockchain. So when I pivot from both the output and these inputs, what I see are the transactions that they are associated with. I see the time of the transaction, the value, the fees, even the block where the transaction occurred. All of this is great for our analysis. So going back, we have over 200 addresses that we want to take a look at and try to get some context for. How, did we approach, narrowing down which addresses to take a look at first, assuming that we didn't have the time to look at every single one of them. One of the things that we did was we chose to narrow down, these addresses by looking at the web messages that they are actually associated with. So if you recall, when we originally ingested the web messages, we had over 6,000 messages, and that can be daunting to go through. So one of the things we did to narrow down which messages we wanted to take a look at first for context was seeing which web messages were actually tied to cryptocurrency addresses. And that reduced our web message set to just 400 nodes, which is really approachable. Sorting by time, you can see just how useful that is, right? We wanted to come in and contextualize these addresses to see how they're being used. What I can see here is in one of the very first messages, that pops up, I have the user Rashev talking to the user Stern, and they're saying, pay me for 2 weeks. Now, granted, we're dealing with translations, so you have to be careful, how you interpret what you're seeing. But here, what we assessed was that we have this user or this threat group member or affiliate or whoever this person is, right? Let's assume we don't know yet. They're talking about being paid. So what we did was we added some context to this particular message, indicating that this is potentially associated with, their operations and then an expense related to employee payroll. I can then pivot over from, this message to the address that's referenced and go to, the output to see if that transaction occurred, and it did. We see that on the same date, June 22nd, this Rashev was sent the 0.074 Bitcoins to this account. So this is the kind of insight, that we got and how we were able to actually contextualize some of these addresses. So not only did we get insight into which addresses were being used for CNO infrastructure, we saw which addresses were being used for recruiting payments. We saw which addresses were being used for payroll here. But if you recall, one of the things we really wanted to, take a look at was like what Bitcoin addresses were being used and associated with victim extortion payments. And to do that, one of the things that we did was try to find an interesting way to approach the data that would help us easily identify that. So to do that, what we did was create a search that would allow us to first lift all of the cryptocurrency addresses that we extracted from this data set, then filter for only addresses that were observed in web messages, And that's just because over time, as we enrich the data, more and more addresses started to get added to the Contileaks research story. But we pivoted over then to payments that these addresses received, and payments that were of a value greater than 15. 15 BTC was chosen because in 2021, while the price of cryptocurrency fluctuates, daily, during that time, 15 BTC could be anywhere between 500,000 US dollars and to up to and upwards of $1 million US dollars. And this seemed like it would be indicative of something more than a normal payment. A normal payment meaning it's not payroll, they're not paying for a VPS server. We know, through reporting that ransomware payments were, $500,000 and beyond potentially. So because of that, we were interested in BTC payments above 15 as a starting point. What this query gave us were some interesting results. If you recall, the data set that we're currently looking at for the messages, it's primarily in 2021. So first, if I look at the payments that were made in 2021, that narrows my set down to, these 3 payments. And then what I was interested in is not only did they make these payments, but I have these payments of 19, 19, and 27. So just starting at this bottom address and going to this December payment, I was really curious, what was this payment for? Is this associated with an actual victim, or is this a large payment and they have a really good, hacker that they want to pay $1 million to? And if so, I need to switch careers. So in pivoting over to this address, what you see is we have this context that is linked to this address. We immediately see them reference, a wallet payment that needs to be made to this address in November of 2021. What we've done is, through our research, we've then gone and subsequently, linked back some of the web messages that we've identified to be referring to this address, even if it doesn't explicitly list it. So let me sort by time here. And what you see is them referring to this address, and they specifically say, hey, this amount, this $1.1 million needs to be paid to this address. This is interesting. And because this was interesting, what we did was we kicked off, a sub-story that we wanted to use for research, and we named it Haiku. So if I pivot to all of the indicators that we have that we ended up linking to this story of Haiku, you can see how many nodes that we've incorporated in this story, this research effort, and also what nodes are included. So everything from cryptocurrency addresses to the transactions that they were involved in, and even the web messages that we were able to assess to be related to this effort. Ultimately, what we found out was that this was in fact related to a victim payment. That victim that they called out was a victim named HKI. And using a combination of time boxing and timeline analysis to keyword searches, so what else referred to HKI, we were able to identify that, this organization named HKI, we see how they're talking about them starting back in November of 2021. And what they're saying about this particular organization, the fact that really they don't appear to have a lot of data on them, just about 8 gigs. They don't care, but they're still going to ask for a high payment amount. And they even list, some of the files that they have associated with this victim. Here, they list the amount that they're requesting and specifically what amount they want paid to where. And then lastly, what they tell us is, hey, there was a payment made from HKI. Using their own internal messages, we can then go back to this address to kind of confirm and see what's happening. So if I go back up to that address, that 1LY address, which is the payment address that was sent to HKI, I can see what transactions, it was involved in. So pivoting from this address, what I see is on 12/1, the same date that the message was sent indicating that, hey, we have a payment from HKI. I see that a payment was in fact made to this address. And this payment is the exact one that they requested because on this date, 19 BTC represented $1.1 million. So this is great. We have a confirmed victim payment, at least by our analysis and our assessment. So while this is interesting and this is great, One of the things we wanted to do is try to take it a step further and see what we can do in Synapse, which is see how we could follow the money. After the victim payment was made to this account, where does the money go? This address was associated with simply or only two transactions. You see the output, transaction, so when it received the money, but then 1221, we then see the money leave this particular address. So these previously unspent BTC coins are now, they're being pushed elsewhere. So where does it go? And you can see that on 1221, this is when the money actually leaves the account. The same exact amount is pushed out in another transaction. If I then click over and take a look at this transaction, I can see that in total, although 19 BTC originated from my victim, from the HKI victim, it's not my victim, but the victim that I'm investigating and researching, a total of 112 BTC was sent out in total. When you pivot over from this transaction, what you see is all of the inputs that took part of, this transaction. And this really ended up being an interesting transaction to take a look at for several reasons. But one, just because we get an idea of how much our victim, put in, but then we also see other victim payments potentially. That was the assumption that we're working off of initially. You have other victim payments that are being sent in this transaction. And you kind of think or wonder, if they are victim payments just by looking at the values. The 19 BTC, 20 BTC, 33 BTC, at that time, it's a range of $1 million to nearly $2 million. That's not, chump change. That's not, normal money to pay for HVAC repair. So this is kind of indicative of, victim payments that's being made to Conti. Also, this was great because by having all of these inputs take place in the same transaction, this then became some additional addresses that we can link to Conti, either as addresses that they use or addresses that they own. So as a result of that, although we originally just started by saying that, hey, this is a Conti, a known Conti address, at the end of analyzing this transaction, what we had were 4 additional addresses that we were able to associate with Conti that were previously unreleased. This is something that we can tag in our system as being associated with them, and also link to the same crypto wallet, so that if we want to then subsequently analyze all of these addresses in concert, we could. So in addition to identifying these inputs, which was great as we tried to follow the money, we then came across an interesting address for output. On 1221, where the money was sent, specifically 100 BTC, which is a great round number, it was sent over to this address that ends in HUSU. When you take a look at this address, you wanted to see what other transactions this address was involved in. What's interesting about this address is that it only was involved in transactions where it received money. None of the money that it received was ever spent. It was never pushed out because we never were able to find any input, any transactions where it served as input on the blockchain. So when you look at all of the transactions that it was involved in, it received money. All of the transactions, when you look at like key patterns in this output data, all of the transactions took place on 1221. They all took place around the same time, right? Which kind of shows, that this is, a part of the operations likely to, have some type of consolidation occur. Then when you look at the actual values that were being sent in, they're all, essentially 100 BTC being sent in. So what this address then represented to us, and at least an address that we wanted to further research, was potentially an address used to consolidate victim payments. And specifically, because at that time, when we were looking at this address, all of those payments still were there. And I believe as of like even a few days ago, this 500 BTC was still just sitting in this account. So the question to us was, is this actually, an address that's used to consolidate victim payments? We have our victim HKI that sent their victim payment there. Are these other inputs associated with monies coming in from different victims? Well, if you recall, there was another address that, I wanted to investigate. Were two more addresses that we could investigate that we identified as making payments higher than 15 BTC. So what we did was we went back to one of those other addresses just to kind of confirm or see if we can confirm that these victim payments were actually being consolidated in this account and if this is an account of interest. So this first, address that we investigated was this 1LY account, and that was associated with Haiku. This next account, this 1KK account, we noticed a transaction, once again, of 19 BTC that took place just about a week prior. And for this, we chose to name this sub-story Ginger Chew, and we investigated this activity. As we looked at the activity for this account, actually, let me go back. What we see is that we had a transaction that took place on the 23rd. And looking at that transaction, if I go back, I'm going to pull up some of the Ginger Chew activity that we were able to pull in for this IP address. When we look at the web messages, we were able to actually go in and confirm yet again that this was another victim payment. And it's interesting that HKI and HDP were actually listed in the same message, but using timeline analysis and taking a look at, some of the data, once again, we see that this is yet another victim account. They specifically have the account listed here. They list the victim organization, and they also kind of talk about what they have on the victim. They talk about the amount of data that they have and also the type of data that they have. So personal data from clients and financial statements for the company. So using all of this, we see, what they're talking about regarding the victim. We even see them say, once again, hey, HDP paid. If I go back up to this address that was given to HDP, what I'm able to then do is go down and look on the 23rd and see that there is a payment, once again, to this address, another $1 million payment. So in us wanting to follow the money, once again, we did follow this transaction. And what we noticed was that this transaction ended up being sent to that same BTC address ending in HUSU that we found for the HKI, for our HKI victim. So to show you what that looks like, I'm going to switch to another view. Right now I'm in my tabular view. I'm going to switch to force graph view, but first let me switch what I have here. So I'm going to switch to force graph view, and also I just switched to another workspace. And when I run this query, what I have is me pulling up all of the indicators that I have that are tagged with Ginger Chew that were associated with extortion, follow the money activity. And I did the same for Haiku. When I hit enter, what I have are, in orange, I have all of the Ginger Chew related activity. And then in blue, I have all of my Haiku activity here. What this address shows is that HUSU address. And what you see is this convergence, right? You see this overlap happen where Ginger Chew activity, ends up coming to this address. So we have some Ginger Chew transactions that end up at just this address. And specifically, this transaction is a transaction that took place on 12/1. That's the only date that this address received some money. And then, on the same date, we have money that was sent from Haiku, right, on 12/1 as well. This really was interesting because it kind of confirmed within the same data set what we were thinking about this particular address, that it was in fact or is in fact used for consolidation payments. And it kind of shows that, hey, they're still active and they're still out there working and having fun. So this was an interesting find among several others. And I guess one of the interesting ones that kind of came out of this, just like at the last minute, was I noticed in looking at this, this visualization here, that there was this address like in green that was linked to Ginger Chew. When you click on it, what you see is it has a story tag of call pipe, which is short for colonial pipeline. So because, Synapse serves as our system of record and we store all of our analysis, not just for this single analysis effort of Conti data, but any analysis that we're doing, we previously analyzed the colonial pipeline cryptocurrency transactions as well. This address was interesting because it was listed in the indictment that was released by the federal government. And specifically, this address was an actual input address. This is where a payment came from the victim to an account that was in use or owned or controlled. It was the extortion payment account controlled by the dark side actors. So it was interesting that this was actually used to make a payment in that particular, attack. But what we see here is that not only was it used as an input payment, for that attack in Colonial Pipeline, but it was also used as an input payment for the payment that was made on 11/23 to the Conti threat group for HDP. And so it just really got us wondering, like, hey, what is this address, right? Does this then represent some kind of third-party payment service? Are they a part of FinCEN? Is this some kind of money services broker? We weren't sure, but this is something that we tagged and we identified that would be cool to continue to investigate for further analysis. So really, in summary, just finding this consolidation account was one of many interesting things that we were able to identify and harvest in this data set. If I come here and just take a look at the cryptocurrency addresses that were part of this data set and pivot to some of the tags that we were able to apply, it really does give you a pretty decent summary of what we were able to find, right? We were able to find additional addresses in use by Conti that were previously unreleased. We were able to identify which addresses were used for CNO operations and for infrastructure, for expenses, just within the organization. And then lastly, what addresses were used for payroll. I hope that by walking you through how we took a stab at looking at the data, and specifically from from a cryptocurrency standpoint, you were able to see just how we were able to use it to do cryptocurrency analysis, but also maybe visualize how you and your team can use it to do cryptocurrency analysis as well. So what we were able to do here is just starting with just a simple tweet. We were able to programmatically ingest the data and enrich those Bitcoin addresses using our blockchain power-up. We were able to contextualize those addresses by looking at some of those web messages and that cryptocurrency transaction data, in parallel. Identify new and unreported BTC addresses. And then as a fun bonus, identify maybe even a third-party broker that may help facilitate some of these victim payouts. That really concludes what I wanted to show you for today's webinar, and hopefully you found it useful. If you have not already done so, what I'd like to do is just encourage you to follow us on LinkedIn and Twitter, even join our public Slack channel, and stay up to date with some of our Synapse releases and publications. Thank you so much for joining us, and I hope you have a great afternoon. Bye.